Hello students, today we are going to discuss in this video about your electrical measurement and instrumentation. And in this video today we will cover the measurement of power by wattmeters and measurement of power. In this session we will cover what is the construction principle and working principle of dynamometer type wattmeter, the errors in dynamometer type wattmeter, what are the methods of corrections, and induction type wattmeters. First of all, we are going to discuss about dynamometer type wattmeter. This is the, you can see, this is the constructional diagram of dynamometer type wattmeter. This is the pointer, this is the scale, this was the scale, this is the pointer, and fixed coil. This is divided into two parts, and between these two filled coils a moving coil is placed, and with this moving coil spindle is attached. With the spindle the pointer is attached over the graduated scale, and with the moving coil a series resistor is connected with the load. Now we will discuss about the load. Now we will discuss about the construction of a dynamometer type wattmeter. A dynamometer type wattmeter primarily consists of two coils called fixed coil and moving coil. In the diagram we have already seen that this is the fixed coil and this is the moving coil. Next, the fixed coil is split into two equal parts which are placed parallel to each other. The fixed coil is divided into two parts which are split into two equal parts which are placed parallel to each other. The two fixed coils are cored to avoid hysteresis effect when used in AC. Then the fixed coil is connected in series with the load carries the circuit current. It is therefore called the current coil. The fixed coil is known as current coil. The moving coil is pivoted between the two parts of the fixed coil and is mounted on a spindle. Then a pointer is attached to the spindle which gives the deflection. The moving coil is connected in the parallel with the load and carries the low current proportional to the voltage. It is therefore called the potential coil. Generally, a high resistance is connected in series with the moving coil to limit the current through it. By limiting the current, the moving coil is made lightweight, which in turn increases the sensitivity of the instrument. The spring provides the controlling torque. They also serve as the additional purpose of leading the current into and out of the moving coil. Air friction damping is employed in such type of instrument. Then its working. When you can say when we are taking dynamometer type wattmeter, we use the wattmeter for power measurement. For the measurement of power, we are using wattmeters. Its current coil is connected in series with the load, carries the load current, and the potential coil connected in parallel with the load carries the current proportional to the voltage across the load. The fixed coil produces a field FM and moving coil creates a field FR. The field FR tries to come in line with the main field FM, which provides a deflecting torque to the moving coil. which will cause the deflection of the pointer or the needle. Thus, a pointer attached to the spindle of the moving coil deflects. This deflection is controlled by the controlling torque produced by the springs. Also read power measurement in 3-phase circuits. Then we will discuss about what are the advantages and disadvantages of a dynamometer type wattmeter. What are the advantages? First we will discuss it can be used both for AC and DC circuits. It has a uniform scale. We can obtain a high degree of accuracy through careful design. And what are the disadvantages? A low power factor, the inductance of the potential coil cause serious errors. The reading of the instrument may be affected by stray fields acting on the moving coil. To prevent it, magnetic shielding is provided by the enclosing the instrument in a nylon case. Errors in dynamometer type wattmeters. Now we will cover what are the errors in this type of instrument. Why errors occurs? In this instrument, error occurs due to potential coil inductance. You can say the inductance of the potential coil is liable to cause an error in the reading of the wattmeter. Because why? Because of this error, the wattmeter gives a high reading on a lagging power factor and lower reading on a leading power factor. The high non-inductive resistance is connected in series with the coil swings, the phasing effect of the potential coil inductance to minimize the potential coil inductance error. Then error due to power loss in the potential coil or current coil. In the potential coil or current coil, due to some voltage drop in the current coil or current taken by the potential coil, an error induced in the instrument. We can overcome this defect by using an additional compensating winding. This winding is connected in series with the potential coil and so placed that it produces a field in opposite direction to that of the current coil. Next, error due to ED currents. The alternating field of fixed or current coil, either of the two coil in the alternating coil induces ED currents in the solid metal parts which set up their own magnetic field. This alerts magnitude and phase the magnetic field, causing deflection. Thus, an error introduced in the instrument reading. The error is minimized or reduced by the solid metal parts are placed far away from the current coil as possible. Next, error due to stray magnetic loss. The dynamometer type wattmeter has a relatively weak operating field. Therefore, stray fields affect the reading of this instrument considerably and cause serious errors. Hence, this type of instrument must be sealed against stray magnetic field. Try using iron cases or providing thin iron seal over the working parts. These are all about your wattmeters, electro dynamometer type wattmeters.